I'm going to introduce Dr.
Anirban.
Anirban. That's tough for an American to say, isn't it? So you've been a serial entrepreneur.
Apparently.
Good for you.
Thank you.
Yeah, you have a couple patents, and you graduate from UC Riverside. So you benefited from an American education.
I did.
Congratulations. I did too. And you have some National Science Foundation grants. What are you going to talk about today?
We're going to talk about protecting cloud servers using user behavior.
Cloud servers and artificial intelligence. All right.
Perfect.
I'm interested. Go
Perfect.
for it.
Thank you. Thank you. Yes.
Eat the mic.
Eat the mic. Okay.
Yeah.
Hello, everybody. So this talk is going to focus on something that has proved to be really useful for us internally as a company and for some people that we have worked with. And so we want to share our experiences with what has worked, what has not worked, and how can you use our experiences, anything that we've learned. This talk is going to focus on protecting cloud servers, anything like Amazon servers, Rackspace servers, whatever it is. And the reason why I want to present this information to people is as an SRE, as a DevOps, as somebody who's doing security inside an organization, it's important to conserve your time. There are so many issues that happen every single day that you're chasing after rabbit holes. You need to understand exactly what's important, what's not that important. The second thing is to maintain our sanity, because when things are on fire, the C-level wants everything to be solved in the next 5 minutes. That's not going to happen. We're going to talk about the status quo when it comes to how do you currently protect access to cloud servers, anything like AWS, Rackspace, as I mentioned. What are the various challenges and threats? And ultimately, we're going to segue into how you can use user behavior in your organization without any vendor lock-in and have better security and control over your infrastructure. So let's jump in. Very quickly, I'm going to gloss over a couple of these slides because everybody here understands what I'm talking about. Cloud servers in most organizations are chopped up in various layers. AWS, like infrastructure as a service. Then there's more Heroku, Google Cloud-like services where expand as you need to and don't worry about the actual server underneath, so on and so forth. Then there's a new entrant Docker, there's Microsoft Azure, etc. These are the things that we're going to talk about. It's also important to understand when you're solving a security problem using user behavior, who is actually using these servers? Majority of the time in most organizations, it's either going to be SRE DevOps or IT or developers or security, but there's also other people who are accessing these servers for different purposes. They might not be as intense or technical as you, but they are also using it for their purposes, whether it might be marketing. Because sometimes you see in companies, marketing wants to have its own infrastructure for some reason. They want to have their own things running on their side. And now what we see in the last couple of years is also the rise of automated software. So most people have heard of or used even Jenkins or some kind of automated testing, Bamboo, build software and such. These pieces of software are also now accessing your cloud servers. It's not just a human, it's also automated processes at scale. Not just a couple of accesses a day, but thousands and maybe millions of accesses a day. How do you make sure it's actually authorized and it's doing the right thing, etc.? We'll talk about that. Very quickly, the status quo right now in most companies, and there are exceptions to this, but in most companies, people are using, hey, LDAP-based username passwords, AD Kerberos-based username passwords. That's how you access a server. That's one way that if you have in traditional companies, servers inside the network, you're accessing it in that way. People think that that's a great way to do things because there is no user account on the server. It gets created when you log in, so that's security. Maybe, but the point being that the traditional methods are still being used. Furthermore, SSH keys is a very popular way of logging into servers, and one of the primary motivators for using SSH keys in most organizations is the ease of use. People don't want to type passwords. I just want to type my SSH command, get logged in. If I have a script, gets logged in, does what it needs to do, etc. Some mechanisms like that. On top of that, people use IP filters to say, well, this particular group of infrastructure can only be accessed from this bastion host or from this particular group of infrastructure, etc., for computer communication. And there's, of course, VPNs and such. So these are kind of the very high-level coarse-grained buckets of approaches that people take in order to protect access to cloud servers. On top of that, there is another layer of abstraction for directory services where you store information about who is in your company, who is allowed to access. So it's one more layer above that. And some of the popular services that we've all heard about and used are Microsoft Active Directory, OpenLDAP, and now even Workday, which is not quite intuitive, but people are using Workday, SaaS-based solution for even directory services. Except these directory services, the previous speaker mentioned IAM, Identity and Access Management. That is also now becoming a big part of organizations where products like, anyway, Ping Identity, Okta, this, that, whatever, they do single sign-on for web apps and they're trying to do IAM for all kinds of things. There is a lack of IAM for infrastructure. There is no obvious IAM for infrastructure. It's very fragmented. The whole system is very fragmented. So let's look at the challenges and threats. Some of these we can relate to directly, but some of these are actually not that obvious because as companies grow, especially in the Bay Area where if you have a startup, you want to hire the right person for the right job, and it doesn't really matter whether that person is in Slovenia or whether they're next to you. It matters a little bit. Of course, it does matter, but you want to get the best person for the job. So you have distributed teams. In traditional companies, everybody would be told, you need to come into the office, we're going to work from here, this is our place, etc. Now you have geographically distributed teams. Furthermore, shadow IT has become a problem. In the latest, some of the compromises that we've seen in my experience, which is shadow IT accounts have been a big enabler of compromises that have happened. And the reason why shadow IT accounts sometimes get used in this manner is because the security level of each one of those organizations might not be as stringent as you. You don't even know who is actually accessing your server. All you know is that you gave an SSH key or a username password pair to somebody in some different country, and that's being used to access your servers. You don't know if it's them or not. You don't know if they're doing the right thing or not. You have some checks and balances, but that's another one of the challenges. The next one is the high velocity of changes. We've changed the way we develop code. We want to have our own Docker instance. We run the tests on our own Docker instance. Everything is done over there. Then I'll push code over there. It didn't used to be like that. So there's a very high velocity of what you're actually doing. You're also consuming cloud resources at a much more higher velocity, where AWS, Rackspace, every one of these providers has provided you with an API, and all you do is you shoot an API, you get a new server, you're good to go. You load it up from an existing image. You don't have to spend time on doing all the configuration stuff. Furthermore, another thing that we've seen is for employee churn, that also contributes to the problem because as people leave the organization, it's not always easy to take away their SSH keys. I bet you that if you talk to 100 companies, more than 90% of them will tell you that a previous employee's SSH keys are still on the server. It's just a fact of life. People want to do SSH key rotations. How many actually do it? Very few. Good for you. Also, the attack surface is changing. Horizontal movement, vertical movement. It's not the traditional types of attacks that are coming in. People are going after privileged accounts. They no longer want to get the sales guy's account because that's too hard to get vertical privilege escalation. Let's get the account for an administrator and see what we can do from there. So the attacks are also changing. I'm going to skip over this slide. We all understand what horizontal scaling, vertical privilege escalation is. Let's talk about going forward. How do we protect ourselves and our infrastructure better? The first thing that I want to talk about is the concept of least privilege. Right now, if you get a cloud server and you get an account, so let's say I go to Rackspace. I have access to the Rackspace console. I start a cloud server over there, and I can connect via a terminal. I can basically do anything that I want on that server. Now, that might be okay for specific situations, but do you want to make that be the default policy that you should be able to do everything on a cloud server or not? Shouldn't you have to earn the right to run certain commands, certain scripts, or do things versus being given the right from the get-go to run things? That's something to think about. Second thing is that any action that people take has to be risk scored. It cannot be without consequences. If you run rm-rf star on a production cluster, you should be fired. So everything should have some kind of consequences with it. You need to understand what is the riskiness, for the lack of a better term. English is not my native language, but
not ours either. It's okay.
So in order to do that, what you need to do is build a pipeline, and we'll show you how we have done it and how you can do it very easily. You have to have a pipeline that actually analyzes all the commands that are being shipped to your actual cloud server from your terminal on your laptop. And ultimately, the model that we are going to build is based on these 4 fundamentals of learning, matching, acting, and updating. And we'll talk about how do you learn, how do you match, what do you match, how do you act, and what do you update. So all this will be coming. So let's jump right into it. That when we talk about cloud servers, what is it that you should be looking out for? If you want to do some kind of profiling, ultimately you're trying to build a model to say, John uses server X in this way. What does that statement actually mean? John uses server X in this way. You have to profile what John does. One of the things that you can do is analyze the commands. What does John run? What level of access does John have? Is he in the administrator group or is he in some other group? Where does John log in from? Etc. So what commands, for example, you've never typed anything related to etc shadow ever. Why are you typing something related to etc shadow now? Those are things that you need to analyze, and you can flag them as anomalies and such. Next thing is that we also look at connection statistics to say, geolocation based, are you coming from a VPN endpoint or not? How many connections have you opened up to parallel server clusters, etc. And these are all signals and features that you can use in order to say whether a particular person or access to a server is valid or not. Is it being used in the right way or not? Another thing that you can do is, when it comes to taking action, obviously any machine learning or AI, I prefer to call it machine learning. AI is kind of like out there. Any machine learning based system, you will have false positives. There is no system that is 100% accurate. If anybody tells you my false positive rate is 0, don't talk to them. It's not possible for real world examples. So what you can do is, when you have false positives, you actually have a graceful way of doing real-time adaptive 2-factor authentication. And we'll show you how we have done it on our side. That's another benefit of that. And ultimately, we'll show you the tools like Apache Spark, PyKit-Sci, whatever we have used to build things ourselves. So you can go home and you can get started. And we'll even give you tips about what exactly to look for in these tools so you don't waste time figuring out a bunch of things that have happened already. One of the ways to make a case to management to make time and space for an effort like this is compliance. They all love the word compliance. Anything is compliance. Oh yeah. We need to buy that tool. We need to do. Oh yeah, compliance. They might not understand what actually is going under the hood, but they love this point. So there are legal consequences of falling out of compliance, whether it's PCI, SOX. There are different types of compliance requirements, etc. What we are proposing over here also helps you with compliance, because for different types of compliance requirements, let's say one compliance requirement says, if an admin account fails to log in 3 times on a server, you need to generate an alert. Things like what we are talking about helps you actually do something like that. It's a tunable system that we have. So now, we've talked about who is using IT resources, what are the IT resources, why is it good, all that stuff. Let's talk about behavior. What do we mean by behavior? So behavior is basically a marker of your identity. That's the way we think about it. So when we talk about behavior, we are talking about what are the types of commands are you using. The first easy thing that you can do is most Linux systems will have some kind of a history file in there. You can grab the history file and you can see what commands have been run, etc. And you can form a Bayesian model very easily, frequency analysis, just very easily to say, out of the 100 unique commands that I see, these are the top 20, these are the middle 20, etc., etc., etc. So this is a very simple, low-hanging fruit that you can apply it to. Any command that doesn't fall within the top 50% bucket, mark it as I don't know. I need to verify, do you really want to run this command? And you can have a Twilio API, basically send an SMS to the guy, whoever's phone it is who's trying to run it, and reply back, etc. You can build your own system, nice little system like this. But that's one of the things that you can look at. What are the types of commands? And directly going to the history and grabbing stuff from there is an easy way to get started and bootstrap the system. Furthermore, it's not just the commands you run. What is the style in which you actually run the commands? What do we mean by style? So a lot of people oftentimes, they will chain commands using semicolons, or they have a specific propensity to use a couple of commands with pipes and so on and so forth. Every person is a little bit different. So we are trying to understand using frequency analysis, how many times does the semicolon come up on usual in every command that you're typing? Are you piping things? What are you doing? Things like that. So to give you an example of what we talked about, here is a very quick screenshot. And I apologize, I don't have a live demo right now, but it'll be available on my website by the end of this week. But so this is basically a very quick example of a screenshot that just shows that I'm just typing a couple of commands over here. What am I typing? I'm just using a well-known piece of software called cluster SSH to log into 2 servers. I'm specifying the where the server is, and I'm specifying the port. So when I type this particular command, I tend to chain things using semicolons, and I just want it to be on one line. There's no good reason for it. I just want stuff on one line. I like one-liners. I write awk and it's one-liners. Everything is one line. So that's kind of something that you can focus on and say that, well, this person, when they type commands, they usually write stuff in one line. Why are they using something else? Those are also markers of your particular behavior. Furthermore, a lot of people, we've done this research where you can easily tell whether it's the right person or not by looking at their mistakes that they make when they type commands. Because it's the way you type actually is pretty unique. You will make the same mistakes moreover when you type commands. If you type list as LITS for some reason, you will make that mistake. You'll use the backspace, you'll come back, you'll correct it, whatever. You will do your thing over there. Furthermore, what we have also found is time of day is not a very good indicator of who is accessing, when are they accessing, is it good or not, but it is a good indicator of a very coarse-grained marker. So for example, you cannot use time of day to say, is it Anirban logging into the AWS server or not? But what you can use AWS, the time of day to say is that, is there an attack going on that AWS server? Because usually during this time to this time, there's between 20 to 50 connections on that server, and now I see 150. So there's a difference between how you use each feature at what granularity. Do you want to bring it to the person? Do you want to bring it to a much more coarser granularity? Another thing that we use is type of resource. So if you're going to assign a risk score to something, you have to also understand how important is the resource. Is it a Docker container that I'm going to not need after 30 minutes? Or is it a production server? Which one is it? So the risk score also has to be predicated on not just your user behavior, the commands, the style and such, but also what type of resource that you are using. As we talked about, if you look at the type of commands that people type, you can have very interesting buckets of the type of commands. Some of the commands are related to network. Somebody's checking how many packets are coming in, is TCP working fine, so on and so forth. You can even create profiles to say, what are the various types of commands, what are the buckets of commands that a person runs. You will find that with SRE DevOps, the percentage of commands they run for network stuff and system stats is much higher than anything else. For developers, they are committing code to GitHub, they're uploading, downloading, whatever they're doing. It's slightly different from that. That's another marker to say, are you in the right group or not? I know it's Anirban. I know he's coming from an IP. I know these are the type of commands he used. Let's try to also analyze the group of commands that he ran. Is he falling in the network bucket? Is he working in the stats bucket? What is he doing? And as I mentioned, we try to do per server profile, per person profile. And that's important because the way you access, again, your Docker container is not the way that you access your production server. There's a difference over it. So you need to also have a different profile for those. When we talk about creating feature sets, there is a some of the things that we talk about is basically to say that when you look at these commands, what is important? You can try to do frequency analysis. That's one easy way to get started with these feature sets. And you have to feed these feature sets to a classifier, something like LAD trees or AD stumps, anything of that sort. One easy way to get started with this is a tool called Weka or scikit-py. Weka is W-E-K-A, and scikit-py, scikit-learn or scikit-py, whichever one. Both of these are really easy. Weka has a graphical user interface. All you do is just feed it a file. It's basically a file with a couple of CSV entries in it. It will load it up. You can do different types of tests on it, etc. Scikit-py is a little more powerful. It's in Python. It's more intuitive, according to me, but you can try any one of these and you'll find that it's easy for you to identify a few features that make meaningful sense to your classification problem. Ultimately, what you want to do with all this feature classification is to obtain a score to say, because you don't know for sure if this person is actually Anirban or not based on their behavior. What we are getting is a score, confidence score to say 0.85, 0.95, 0.9, what is it? How much confidence do I have in saying, is this the guy or not? You have to then set thresholds to say, you know what, if it's below 0.75, just don't let the person access AWS. I don't know, it's too much of a... And this is one of the problems with this approach where there is no one size fits all. There is no magic bullet that is good for you and is good for me. The amount of false positives that I can tolerate in my company is different from the amount of false positives that you can tolerate in your company. So there has to be a way to change those markers and say, is it 0.75, is it 0.8, is it 0.9? How accurate do I want to be? How pedantic do I want to be? Etc. When we talk about classification, there are basically two basic groups. One is supervised learning and one is unsupervised learning. For supervised learning, there are various classification techniques like Bayes, SVM. If you get your hands on Weka or scikit-py, I would recommend that go with SVM. SVM is a simple method, it's easy to understand, and it helps you that if you have n-dimensional data, it's easy to create a plane through that data to separate the data points into good and bad, good and bad. So instead, I would encourage you to try out different models, different algorithms, everything, but if you're looking for quick bang for your buck, go for Bayes or SVM. It'll give you good results very quickly. And there are specific reasons as to why. For unsupervised, you can use something like k-means or expectation maximization, etc. But my favorite is SVM. It works really nice for us. One thing to keep in mind is, as we look at all these features and we say, oh, maybe this typing style makes sense. Maybe the number of semicolons makes sense. Maybe this makes sense. Maybe that makes sense. What you're actually doing is creating all these feature sets to say, is this important? Is this important? Is this important? Etc. If you use Weka, it has a very nice graphical, easy way to also show you something called PCA, which is Principal Component Analysis. And it's a fancy word, but all it basically does is it shows you, out of all these features, which one's really important. Which ones should you be focusing on? Should you be focusing on everything? Or should you be focusing on these 5 or these 10 instead of these 50 that you think are important? Because ultimately what you want is to have a very targeted set of features that you're looking at to get good prediction accuracy. Another thing that to keep in mind when you do this is more data is not always good. Primarily because there's bias in the data. Sometimes the data is dirty. There's different types of issues with it. So what you should try to do is get a chunk of data, develop your system on top of that data. If you see you're going in the right direction, then you can add more data to the classification issue itself. But don't just add more data like, oh, I have 10 GB now, so 20 GB will obviously be better. Now 30 GB will obviously be better. It doesn't work that nicely. I wish it did, but it doesn't. There's bias, there's noise, there's different types of issues. One of the common things that we sometimes get sucked into is more features is always good. Obviously, if I have to say, is this a phone? Well, it's white, so it's an iPhone, and it's like this, and it has glass in the front, and it's got a battery. Obviously, it's a phone. So if the normal way of thinking is, if I add more features to this classification, it's obviously going to be better. That's not always the case, primarily because if you think of a three-dimensional space, and there are points in that space, the more features you're adding, the envelope that can separate whether this point is inside a bubble or this point is outside the bubble, as you add more features, this bubble is no longer a sphere. It turns into an ice crystal, where each data point is at the end of an ice crystal. The problem that happens with doing something like that is, in the real world, when you will throw points, data points for classification at this ice crystal, it'll tend to fall outside and not really give you any kind of useful measure of accuracy or prediction. So always having more features doesn't mean that you'll have better prediction. So how do you actually make the data actionable? Let's say you found a way to qualify and quantify that this is Anirban, he's accessing this server, everything seems good. Now if everything doesn't seem good, what then? How do you make it actionable? One of the easiest ways is that you can kill the session, you can change out the SSH keys immediately, not let that person have access again. If you don't want to go to that extent, what you can do is build your own custom 2FA implementation where you can just send an SMS to somebody or use an existing API that another service offers and just ask the person, hey, use the fingerprint sensor on the phone and tell me you're trying to run RM-RF star. If they do, sure, let the command go through. And this is a graceful way of handling false positives, because otherwise you would need to have an IT administrator or a dedicated security person looking at all the commands that get flagged and making a decision on, well, does he really want to run this thing? Why guess when you can have the person say, yes, I really want to run this thing? There's a slight difference there, but it works really nicely. Another thing is that you can, if you go down this route, you can have some really nice layered authentication and authorization going on. So say, for example, if I'm trying to access a server and I'm trying to do something funny to that server, you can send me a two-factor notification to say, oh, Anirban, are you trying to run this particular command on this server? At the same time, you can send a notification to the IT owner or the business owner of that specific server cluster that Anirban is trying to run RM-RF star. Should we let him run it or not? So you can have 2-man protocols, 3-man protocols, whatever you like. It's all based on this entire mechanism. You can also do dynamic ACL modification. Ultimate goal being, if you are trying to do something bad, we should restrict your privileges in real time. If you're fine, do whatever you need to do. And this also forces the attackers to learn how you use cloud servers. If I steal your SSH key right now, I can go in and I can do my things in most cases, but it forces me as an attacker to also learn what are you actually doing. One of the things that we all need to understand is systems need to keep learning, so there has to be a constant stream of data. You cannot just grab data from history files or from a SIM log and train your system on it and then let it loose, and then you cannot expect that people will not complain about it. Primarily because the way people are using the system, you need to refresh it with the way people are using different types of servers. We can think about rule-based approaches, but we shouldn't obsess about it, primarily because rule-based approaches, some things are very common sense, they'll work nicely, but when you start to scale, how many rules will you write? It's not possible. You cannot predict. It's like asking somebody to look into a crystal ball and say, well, what's going to happen tomorrow? I don't know. So you can't really keep writing rules. This also helps with auditing shadow IT accounts, as we mentioned, so that's another benefit. Very quickly, so let's go to the actual tools that we can use to build out this pipeline. Some of the freely available and actually very easy to use tools that you can get started within like 15 minutes, that's enough to get started, is actually scikit-py or Weka. These are very easy to use tools. You can download them all, and there are even tutorials to give you data sets to tell you that, oh, would you like to try out expectation maximization? Would you like to try out k-means? Here's the data for it. So that's very, very helpful. The second thing is, a lot of people have probably used it or heard of it, is Kafka, Apache Kafka, which is basically a way to gather a lot of data from endpoints and pump it in a reliable queue way to your system. We have used Kafka, and what we've found is it's a good way to shift bits or information from a lot of endpoints to our analysis system. On top of that, there is another piece of software called Apache Spark. Again, people might have heard of it, used it. Apache Spark is a good way of doing distributed number crunching, whether for statistical purposes, whether for heuristics, whatever you need. So if you are trying to find, say, running means of something, because that's what your algorithm is based on, you can do that very fast, very reliably, with very low effort. So these are, again, very useful. I mentioned Twilio, just an example. You don't have to use Twilio for sending SMSs or anything. You can use whatever you like. It's just an example. We have used Node.js internally for a couple of our services. You don't have to use it. You can use whatever you like. But this is basically the stack that we have, and the first three ones are the ones that help you develop the plumbing for this entire system. Again, as I mentioned, when you start off with Weka or when you start off with scikit-py, look at SVMs, LAD trees, AD stumps, things like this. They will save you time. You don't have to go and experiment with every single thing under the sun and then find out, well, this doesn't really work well for this data set. So what does the plumbing ultimately look like? One thing that we have not mentioned till now is, in order for you to actually make this actionable, you need to have some kind of a SSH proxy. Otherwise, there is no real way for you to take action on it. So let's say if you are going to type rm -rf, whatever the command is, I have to have a way to stop that command from hitting the server. If I don't use an SSH proxy, it's very hard for me to do that. I have to go to the server, install PAM modules, etc. I can do it on the server side if I wanted to, but the downside of that is I am modifying my server images, which I don't want to do. That's just our use case. So we use an SSH proxy. And the way we use it is, if you assign a server to us and say that, you know what, protect this particular server, it assigns, you can use dynamic DNS to basically tell the user that, hey, yesterday you typed sshjohn@server1.com. Today you'll type sshjohn_server1.com at yourcompany.com, whatever that might be. So that's one easy way to also put it into scripts and let them just go crazy through the proxy and do their thing. So because everything is now going to the proxy, of course, the question being, is it a single point of failure? Yes. So you need to have multiple proxies. The great thing about that is you can always argue for more time or budget for doing that by saying, look, we need to have separation of duties and separation of traffic. So dev traffic goes through this proxy, test traffic goes through this proxy, production traffic goes to this proxy, customer traffic goes to this proxy, etc. You can neatly lay that out. What we can do is, the potential workflow that can happen is, when you attach a particular server to this system, it goes in and automatically changes out all the SSH keys for the users that are on that server. Once it changes out the SSH keys, it basically, ultimately what will happen is you will type the new SSH command, you'll connect with the proxy using your existing key on your laptop. There's a completely new key pair that opens up a tunnel on the other side, joins it in, and because we are joining it in, you can do introspection to say, command introspection to say, what are you typing? We are not going to let this command fly, etc., etc. That's one approach that you can take. And of course, as I mentioned, you can use SMS, email, whatever you want to tell anybody that things are happening. But the interesting thing is that you don't have to just stop here. Once you have your system, why stop at cloud servers? You can also profile cloud apps. The way you behave on PayPal is different from the way you behave on Facebook. How many clicks do you do on Facebook in 10 seconds? How many clicks do you do on PayPal in 10 seconds? How much do you scroll? What is the curvature of the mouse when you move things on Facebook and PayPal? These are all markers that you can again pull out. And the way to implement a very simple solution, low effort, browser extensions. Browser extensions are really powerful. You can gather a lot of information from these to say like what's actually going on, etc. There has been a lot of talk about using typing patterns in the past. Just wanted to clarify that we've done some experiments and our experience has been typing speed is a very poor indicator and is fraught with false positives. For some reason, we've never been able to use typing speed as a good indicator of if it's you or not. Primarily because people will make mistakes and their typing speed will change. It's always a little bit of like pain in the behind. Just because typing speed is not a good indicator, it doesn't mean typing patterns aren't a good indicator. A good indicator is something like you going on a site. Think about this. You go on a site, you see a registration page which says first name, last name, da 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 da. You have a way of going through all these fields by using the tab or by using the mouse, and people do it in different manners. So that's one indicator which is actually pretty good to say that when you visit a web app, you actually use tab to navigate through all the form entries. The good thing about going with this approach is that you will not have any vendor lock-in. There is no software that you will have to buy. You can build your own thing. You can customize it as you want for whatever you like. You will have the option of deciding how you want to do false positive mitigation. You will not be held back by a vendor saying, this is the way we do it and that's how it's going to happen. Your data is in your control, and ultimately you will have adaptive two-factor authentication with 2-man protocols, 3-man protocols, whatever you like. The point being, if your infrastructure in your company is divided up in various buckets, it's really important, it's meh, who cares? That's kind of the spectrum in most companies. If it's really important, you have the choice of saying, how much adaptive two-factor authentication should I put in front of there? Because you're doing it in a real-time way. And the good news is, this is actually low friction. When we have used this with other people, they found that pushback from internal employees is much lower if you do it like this versus other challenges that we faced in the past. Again, as I mentioned, we all need budget and time for doing something like this. Here are some pointers as to how to make the case to C-level to say, look, I really want to do this project. It's going to help us. This is what we're going to get out of this project. So again, throw in compliance. You can say, hey, it's going to protect customer data. It's going to be harder for somebody if they ever break in to actually get access to customer data, better control, and ultimately time savings for IT will be more efficient, etc. So there are some points to be made in order to say that is this a good investment of money? And the ultimate point is don't end up on TechCrunch or Forbes or whatever. I'm not picking on Snapchat, but I'm just saying that things happen, and nobody likes bad publicity. But this was a very quick presentation, and we didn't discuss the mathematical aspects of a lot of things. But the good news is that if you try those pieces of software, if you look at those LED trees and SVMs that I mentioned, it's actually very easy to get started. And the good news is that we all, when we work with in technology companies, we have access to this gold mine of data. Just think about the history data that you have on all your servers. That's it. Next step is going to the SIM and pulling out information from Splunk or Sumo Logic if your company uses anything of that sort. So the possibilities are actually endless what you can do. And the good news is you control the security envelope, not a vendor. You control what is right for your organization, not somebody else. So I'll stop here, but if there are any questions, I'll be happy to answer. We built our own sorry. Yes. So the question is, what do you use as an SSH proxy? We used our own solution, but we are going to make it available for everybody from our GitHub page. So you don't have to develop one yourself. But realistically, you can use nearly any SSH proxy, open source proxy that's out there. And for a couple of ones that we have looked at, one is called SSH Piper. It's actually very easy. It's like 4 lines of code that you need to put in to basically do command introspection and things like that.
How do you address when a particular command you run, when it runs on the server, allows other commands? So like from CI, if I want to run a command from like I type of CI is the command. First of all, it's interactive.
Yes.
But also then I can potentially from CI write to another file.
Right.
How do you incorporate that kind of malicious action?
That is a good question. We don't have a good handle on that. The question was that if you have an interactive VI-based session and you're trying to run commands from VI, how do you stop that? We don't have a good handle on that. Yes.
One question. So if your solution is not logging, you mentioned you have a proprietary SSH Proxy. So if you're not logging it yet, you should definitely consider upping your verbosity on SSH and trapping the SSH client string.
Right.
And there's gold there. If you're not already.
Yes.
So see deviation from whatever. It's very high signal.
Yes.
And two, does your proxy trap tunnels and version?
Yes, it does. Yes, it does. The question was, the point is that if you are not already looking at the string agent for SSH with the verbosity flags, you should look at it because that is a good piece of information. That's a good marker. So definitely something to keep in mind. And does our own solution look at -r tunnels? Yes, it does. Yes.
So I absolutely think there's room for machine learning in this type of thing, but I think a lot of issues with your statement about writing actual the important use of tools. You mentioned a lot of tools, but what data goes into it? The thing I really heard was the history file, which doesn't really scale for many reasons, right? The shelves, there's different OSs, there's app areas, and things on history file. There's a lot of reasons that doesn't work. I think your statement about the plays is misleading, and folks starting it up, I think that's exactly where they should start. Listing out threats that are specific to their environment, and then identifying the data that's going to give them those threats, and then going after that data, rather than saying, what infrastructure are we employing to throw this magic data in to make these magic alerts? I think it's a little idealistic. I think there's more fundamental things we need to happen. Well before that.
Sure, I appreciate that. Yeah. Sure.
If you're done, any more questions? One in the back.
Right. So what we've seen is in certain types of scripts that we have analyzed with people that we've worked with, they are running when we look at our proxy, we see certain commands that are coming in using in a chained fashion. So rm being changed with something, cat, etc., etc., etc. That's one indicator for us to say when somebody's running a particular script that we know about, it's usually running with these 3 piping commands, etc. But if that suddenly changes, that's an indicator for us to say that, well, it's falling outside the classification envelope. We'll have to do something to make sure, send a 2FA notice to the actual IT owner and say that this script is trying to run this particular command. Should we let it go through or not? Yes, it has to, because I mean it's not as real time, but we take chunks of 5-minute intervals and we try to update it, because it is realistic that people will change a little bit that they are accessing the server, so you have to get that new information.
Okay, Anirban, I would thank you.
Thank you
Did
very
I get
much.
your name right?
Yes.
I've been practicing for an hour.
Thank you.